Hello, my name is Thomas. I'm super excited to talk to you today about artificial intelligence and a little bit about 3D printing. And I'm stressing today because these technologies are very much today, not tomorrow. For instance, in SwimCam, the company I co-founded, we are creating an underwater camera that you, by the press of a single button, gets a stream from underwater directly to a tablet. Swim coaches use this to get that extra set of eyes underwater so that they can give detailed technical feedback to the swimmers on a continuous basis. Because as a competitive swimmer, it's sometimes the length of a nail that separates the winners from the runner-ups. So we've created this camera using 3D printing. What you see here is the bottom shell of it. So this is a physical manifestation of our designer's idea about how it should look like. So in a 3D printing process, what happens is that the designer visualizes a concept. He puts it into bits and bytes. And these bits and bytes at a later stage get into melted plastic, metal, or whatever comes out of that 3D printer. So in this whole process, it gets from the mind of a human into bits and bytes into a physical form. And the interesting part is that at this conversion stage, at a certain point of time, it's bits and bytes. And when it's bits and bytes, we can manipulate it. We can use various techniques to improve those bits and bytes. And that's where 3D printing and artificial intelligence intersects. Within artificial intelligence, there are different techniques to create intelligent systems. One of them is called genetic algorithms, and it's built on the principles of survival of the fittest. The idea is that, like on the plains of Africa, the programs in a simulated environment battle for resources in order to create the top predator, the top animal, the best solution to the problem that you're looking for. This principle of genetic algorithms have been used in design for quite a while, and it's called, in that, generative design. In order to illustrate the opportunities of generative design, Autodesk, who creates most of the software used for industrial design, decided to embark on the Elbow project. The Elbow project was about these two chairs. The idea was to make a 3D scan of the chairs and then kind of make the computer elaborate on those chairs, like create offsprings, different variations on them, and try to see what came out of it. In the process, designer looks at the offsprings of the two chairs and kind of decides who's get to live and who has to die. And that process iterates and iterates and iterates until you get a chair that the designer is satisfied with. So the software looks a bit like this, that you put in the chairs and then you start running the process and you get all these chairs that are basically generations of new offsprings. And in the end, you end up with the chair when the designer stops the process. And the chair that in the Elbow project came out of it was this chair, the Elbow chair. So what do you think of it? Most people are kind of like, I like the others, but some people really like this chair. One thing is for sure, this chair looks a lot more organic than the original chairs. And isn't it interesting that when we start using AI and computers, we don't get chairs that are more bulky or mechanical or industrial, but they look kind of more organic. That sense of kind of evolvement and organic shapes you can also see in other designs made by generative design. But are we swimming too fast here? Have we a good grasp on what AI really is? Or are we getting ahead of ourselves here? I've been within artificial intelligence for more than 20 years. I've done a PhD within computer science within artificial intelligence, and I still have a hard time defining what artificial intelligence really is. Let's dig deeper into why that is the case. This is Sebastian Thrun. In his late 40s, Sebastian starts exploring how can we detect cancer at an early stage. Perhaps it's because his own mother died of an undiagnosed breast cancer that had gone all the way to stage 5. And if we look at the statistics, it gets pretty grim when you get to stage 5. If you're at the early stage of stage 0, chances of survival are very high. But as soon as you get to stage 5, the outlook are pretty grim. So Sebastian wants to solve this problem. But he doesn't throw himself at breast cancer, but rather he throws himself at skin cancer. Skin cancer is the most common form of cancer. Together with a group of PhD students, he starts building up a library of images. A library of images of skin cancer. Because Sebastian Thrun is not just Mr. Anybody. He's one of the top researchers within artificial intelligence. And he has this idea that by using modern neural networks, kind of an imitation of the human brain, we can have computers recognize which of the images are skin cancer and which are not. So together with a group of PhD students, they collect all these images and they ask trained dermatologists to kind of recognize what is what. And then they train the neural network. And by the end of it, they can publish an article in Nature, this one, that basically shows that if you have a trained neural network that actually can run on a phone, you can get a computer to diagnose skin cancer at the level of a trained dermatologist. But is this really artificial intelligence? Some would claim that it is artificial intelligence because the computers can actually learn to diagnose skin cancer. But a lot of people would say, well, nah, it's more just computers processing a large amount of data. Like when my phone is recognizing my face and opens up, that is not an intelligent phone, that is just a smartphone. So we're not really there yet. And they are both right. This is the field of machine learning, where the whole idea is that we build intelligent computers by making them learn from data. That is one big approach to creating intelligent systems. The other approach is called symbolic machine learning or rule-based machine learning, or sometimes also referred to as GoFi, good old-fashioned AI. And let's see an approach on how that is. And that was, so let's look at an example of GoFi. This picture was taken in 2011, 10 years ago, when IBM's Watson was playing the two most winning grand champions in US history ever. The joke was actually that this guy was bred through generations with the sole purpose of playing Jeopardy. That is how good he was. So let's see how it went. Those more than 10 years ago, when IBM's GoFi system was playing the grand champions of Jeopardy.
Gentlemen?
Good morning, everybody. Thank you for being here. What do you say we play Jeopardy? Let's get right into the Jeopardy round. These categories: a man, a plane, a canal, Erie, Chicks Dig Me, children's book titles, My Michelle, MC5, and finally, vocabulary. Ken, you're in the first position. Please make a selection.
I've never said this on TV. Chicks Dig Me for 200, please, Jimmy.
Kathleen Kenyon's excavation of this city, mentioned in Joshua, showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her archaeologist hubby dug in hopes of finding the lost Syrian city of Urkesh. Watson.
Who is Agatha Christie?
Correct.
Same category, 600.
At the Olduvai Gorge in 1959, She and hubby Lewis found a 1.75 million year old Australopithecus Boise-eyed skull. Watson?
Who is Mary leaking?
You're right.
So the question is, of course, again, is this an intelligent system or is it not? Some people will claim, yes, it is intelligent. The system is able to answer questions it has not been posed before. Other people would claim, nah, it's more of like advanced Google searches. All the data is in the database. It's just about combining those data to answer a new question. So let's pause for a second and say, okay, let's assume that the guys building Watson and the girls building Watson and Sebastian Thrun, instead of building those systems, spending all those time in front of computers, they spend time training this pig. So in this picture, you see a pig that is not only able to swim beautifully in the sea, it's also able to diagnose skin cancer at the level of a trained dermatologist and can answer any question in Jeopardy. Would you claim that pig to be intelligent? I guess most people would. And that is interesting because as soon as we put systems into these computers, phones, or whatever, we have a tendency, or most often we call them not intelligent. They're just computers doing calculations on a vast amount of data. But as soon as the intelligence is living inside something that resembles us, a mammal, we kind of have the conclusion, well, it must be thinking the same way as we do. And hence, it's intelligent. And that is a really important thing about artificial intelligence and intelligence in general. If the intelligence resembles us and the way we reason, the way we think, then we perceive it as intelligence. Not if it's done inside a computer. So our notion of intelligence is much more related to where it resides than what it can actually perform. And that is why it's difficult to define artificial intelligence. So we have a hard time really putting the boundaries around what should a system be able to perform in order for us to give it the label, this is artificial intelligence. And the problem actually comes from a much deeper level. It's our challenge of defining what intelligence really is. Try to think of the person in history that you connect to the notion of intelligence. If you were to design a dictionary where you should put under human intelligence the image of a person, who would you put there? Most people would put this guy, Albert Einstein. Isn't it amazing that there's one person in history that everybody connects to the notion of intelligence? You wouldn't put Donald Trump, for instance. I guess some people would. And that shows another feature around intelligence, that at the one end of the scale we got ants, chickens, monkeys, people, politicians somewhere, and geniuses. So no matter how we put it, intelligence is not a question whether it's there or not, it's a question of scale. And we should apply the same principles to intelligent systems or artificial intelligence. It's not a question whether it's intelligent or not. It's a question of to what scale the system is intelligent. But is it really true that we cannot define intelligence? Well, a lot of people have tried. In 1994, all of these professors sat down to figure out what is really intelligence. And they came up with this. It's the ability to reason, plan, solve problems, think abstract, comprehend complex ideas, learn quickly and learn from experience, but also more fuzzy things like catching on, getting a sense of things, and so on. So what all of these professors and researchers really agreed upon was that we really don't know how to define intelligence, but we recognize it when we see it. And since we cannot define what intelligence is, then it becomes practically impossible to define what artificial intelligence really is. So what we mostly use is kind of like the notion of the early days of artificial intelligence, when guys like Arthur Samuel here said, well, artificial intelligence is a field of study that gives computers the ability to learn without being explicitly programmed. In other words, we don't have to tell everything to the computers beforehand. They should be able to figure stuff out themselves. And that is really where we're heading with artificial intelligence. It doesn't have to be computers that can solve everything. They just have to be able to do stuff that we don't program them explicitly to do and that help us do stuff. So in the beginning of this video presentation, I said that artificial intelligence is very much today and not only in the future. And yet I've only given examples of research institutions and big companies developing AI. But AI is really today. I'm sitting at an incubator at the Danish Technical University called FutureBox. And I think there's only a single company on our floor that is not using AI. So let's look at what they're using AI for. First up is Godogo. Godogo is a company founded by dog lovers that deals with the challenge of dogs and canines are getting bored at home when their dog owners are out at work. So in order to stimulate the dogs, they have invented this gaming platform where dogs can play different kinds of games and the results are thrilling. Dogs love the games and so does their owners. And they're using artificial intelligence in the camera to recognize what are the dogs doing and are they playing the games correctly? Are they doing the right moves in order to get the treat that is a benefit of this game? That is just one company. Another company here is SyncSense. What they are doing is that they are providing therapeutics to elderly based on virtual reality. So they are bringing elderly people back to the neighborhoods, this forest, and everything they were experiencing when they were young. And they have a small sensor kind of determining where they are moving, and hence they can create this virtual world around the elderly that engages them in physical activity. And that is actually a really big problem, that a lot of elderly people are not active enough. But in this, again, kind of gaming environment, they get the sense of being back to where they were once in life. The third one is Senstec. They're putting data collecting souls under people with Parkinson's disease. Because one of the big problems with Parkinson's disease is that you actually have very big difficulties in giving the right medication. So what they are doing is that based on measurement, they can actually measure the effect of the medicine on the patient and adjust the medicine so it's just at the right level of the patient. But of its course, it's not just the small companies. It's also big companies developing artificial intelligence. And it is the big companies that is driving a lot of the development within artificial intelligence, from self-driving cars to diagnostic to whatever. But there's one area that you're already aware of that I think is very, very interesting, and that is speech technology. You probably already know Alexa here, and Siri, and Google Home, the virtual assistants that we can talk to and give simple commands. They have been rapidly developing for a few years. And if you just open up Word and press dictate, the speech recognition is so much better than just a few years ago. With spam filters, the kind of level where we could use them at all were when they were at 90%, leaving 10% spam getting through. When they were at 98%, everybody was using them. And speech technology is slowly progressing at about 2% per year. So we're getting much better speech recognition by the year. And this is one of the areas that I find very, very exciting because it enables us to communicate with the computers in something that is different than really a modernized typewriter and a screen. We are in the future able to talk to the computers and interact them in an entirely different way. As this shown by Google, a system that they have been using and have been in production for more than a year. So what are you thinking? I think this opens up for a whole Pandora's box of questions on ethics and everything else and humanity. So we're starting to communicate with computers and we can't really recognize whether it's computer or human. So where are we heading with this? I think it's super exciting, and that's why I really like being within the field of artificial intelligence, because it's not just about technology, but also very much about the nature of humans, how we perceive ourselves as humans, what we think is intelligent, what we think is thought, and how we would like the future to be when interacting with computers. So, remembering the old words from Douglas Adams, anything that was in the world when you were born is normal and ordinary and just a natural part of the way things work. Anything that was invented between you were 15 and 35 is new and exciting, revolutionary, and you can maybe get a career within it. And finally, anything invented after you were 35 is against the natural order of things. I think when it comes to AI, age doesn't really matter, but there's a lot of other things that matter. So let's see where we are going. I, for one, is very excited about it. Thank you for your time.